Yeah, hi. In this tutorial, we are going to continue with the Pandas data frame. Okay, so we'll start with the apply function. So what apply function does, it actually, let's say if the requirement is to apply a given user-defined function or a lambda function or a predefined function on each of the columns of a row of a data frame, then we can use apply. So let's say we create a data frame. To start with, first we are creating data, which is a numpy array. I'm just using the rand int function to generate the data randomly between these two values. Lower value is 10 and the higher value is 20. Now column is we are creating just columns in the form of q1, q2, q3, q4. Let's say in the form of the quarters, and index is basically a list ABC. So we create the data frame df, which is data frame. Data is what the data we created using the numpy array. Columns is the calls, and index is this. So this is the data frame we got created. Let's say this q1, q2, q3 represents the quarterly sales of three products A, B, and C, and this data that we just generated randomly using rand int. Now we can apply the apply function. uh, let's say our requirement is to find out the total sales for each product in a year. So we have this product A, B, and C. I want the total sales of product A across all these quarters, total sales of product B across all these quarters, total sale of product similarly C for across all these quarters. So what we are basically doing is we have to sum it across the along the columns. So how do we do it? We say df.apply. So apply is the function that we're using. Now which function we want to apply is sum. Okay, so some function is going to be applied. Now along which axis we want to apply this function? We are saying x is equals to 1. So along the columns, this function sum will be applied, and we will get the sum of all these values. That is sum of all the values of all these quarters, and we'll get the sum of for products A, B, and C. Let's say if the requirement is to find out the total sales for all the products in each quarter. Let's say what was the total sales in quarter 1, what was the total sale in quarter 2, quarter 3, and quarter 4. So basically this time what we want to do is we want to sum along the rows. So we say df.apply, and the function that we want to apply is np.sum. Basically we want to do the summation, and we want to do the summation along the axis 0, that is along the rows. So along the rows it will be summed up like this, and this. So we will get values for quarter 1, 2, 3, and 4. So it means quarter 1 we had sales 39, quarter 2 39, quarter 3 42, quarter 4 45. Now just taking it forward, we can apply another other functions like max, min, mean along the different axes 0 or 1. Let's say the requirement is to find out the maximum sale for each product across all the quarters. So I want to find out for each of these products A, B, and C, what was the maximum sale. For example, for A, the maximum sale was in quarter Q1 and it was 18. For product B, the maximum sale was 17, and for product C, it was 16. So what we have to do, we have to apply the function max, and this time along the columns. So we say df dot apply, and the function that we want to apply is np dot max, and this is along the columns. So we say x is equals to 1. So we get the maximum sales for each of these products across all the quarters. Let's say we have to find out what is the average sales for each of the products across all the quarters. That is for product A, what is the average sale across all the quarters. Similarly for product B and C. So again we have to apply the function along the columns. We say df.apply, and the function that we want to apply is np.mean. That is, we want to calculate the average, and x is equals to 1 means that is along the columns. So this gives the output of A, B, and C, and this is the average sales. Okay, the next function we are going to cover is aggregate function. Let's say the requirement is to apply more than one operations along the axis, maybe axis 0 or axis 1, and then generate the values. Then we can use the aggregate function. So continuing with the same data frame df, so the sales across the 4 quarters Q1, Q2, Q3, Q4, and these are the products A, B, and C. Now let's say the requirement is to find out the minimum, maximum, and the mean value for each of these products. So we can apply all these three functions in one go using df.aggregate. So df.agg, and we can specify whatever functions we want to apply, like min, mean, max, and this is along the axis columns. Either we can give axis equals to 1, or we can say axis equals to columns. It's the same thing. So it will calculate for each of the products along the axis, that is columns, that is along this way. What is the minimum value? Minimum, for example, for A, minimum is 10, mean value is 13.25, and maximum is 18. Similarly, for B, the minimum is 10, mean is 14.75, maximum is 17. For C, minimum is 10, maximum is 16, and mean value is 13.25. Now we can apply the same function, and this time along the rows. So we can specify df.aggregate. The functions that we want to apply are minimum, let's say median, and maximum, and x is equals to rows, or we can give x is equals to 0. So along the rows, the function gets applied, and we get minimum, median, and maximum values for for each of these quarters Q1, Q2, Q3, and Q4. The next is the transform function. So basically, transform function is used to apply a function on the values, and it generates a new data frame. Let's say we want to find out the square root of each of these values of the data frame and generate a new data frame. Then we simply say df.transform, and within bracket we specify which function we want to apply on the original data frame, so that the new data frame that we get contains this transformed value based on this function that we are passing it. The next topic we are going to cover is the group by. So let's say we have a data frame called as student, which we created based on the other two data frames, math and the science, which contains the students roll number and marks for the subjects math and the science respectively. And then we are also capturing the gender of the student. So first we create two data frames, maths and science. We just simply append it, maths dot append and science, and the result we store it in another data frame called as student, stud, stud, and we just simply display it. So what we see here is in the indexes the roll numbers of the student, and the subject. In the subject we have math or science, and the marks obtained by that particular student in that subject, and the gender of the student. So on this data frame now we are going to apply the group by. So to start with, let's say we want to find out the average marks for each subject. So now we have two subjects, maths and science. We want to find out what was the average marks obtained by student in each of these subjects. So basically we want to group by on the basis of the subject, and then for the and then we want to calculate the average of the marks. So how we do this? We say stud, which is the data frame dot group by. Now we want to group by on the basis of column subject. So we specify the column subject, and then we select the column marks, because on the marks we want to apply the function mean, which is like to calculate the average. So it's group by on the basis of subject, and on the column marks just calculate the mean, that is the average. So we'll get math 75.4 and science 72. So it means the average marks of maths was greater than the science. Now, taking it further, in this example, we group on the basis of one column. We can also group on the basis of two columns. So let's say we want to group on the basis of subject and gender. Then we specify these two columns as a list in the group by function. So we say student dot group by, and the columns are subject and gender, so we are grouping on the basis of subject and gender both, and then on the marks column we are calculating the average, that is mean. So in the output we get something like this, where this is marks and this is subject, which is math, and the gender is male and female. Similarly for science, gender is female and male, and what is the average marks obtained by the students. So we see that based on this data, females score better than male in both subjects, maths as well as science. Just a second, please. Okay, now just to take it further, how the actually operations take place when we group by a data frame based on any column. So let's say we group this student data frame on the basis of subject column. So let's say student dot group by, and we specify the column subject, and we store it in G. Now basically G contains, now we want to go through the elements of the G. So how do we go through it? We just want to loop through the elements of G. We say for subject comma frame. So G basically contains the individual subject and the data frame. So we are printing the individual subject based on which the grouping was done, and then we are printing the corresponding data frame. So for each subject and data frame in G, print the subject and then print the data frame, and then we are just simply printing the line to just separate the groups. So in the output what we get is, so for subject math we are getting this data frame, and for subject science we are getting this another data frame. So it means, so whenever we are doing this group by, what it does, for each of the values of the group by column, let's say here it's a subject, so the values are maths and science, it creates a small data frame which belongs to corresponding to the value we uh, the value which is selected in the group by. So it got two different values in the for the subject. One is maths and one other is the science. So two groups got created from the original data frame. So this is group one for math, and this is the group two for science. Now uh, let's say if we want to find out what are the indexes of a particular group, then we can say g dot groups, and then we can specify the value of the group, so the value based on which the group was created, then it will return the index for that particular group. Now for a given group value, if you want to see what the data frame it is, for example in this particular code we are printing each value of each value based on which the grouping is done, and then we are printing the corresponding data frame. There is another way is to, for a given value of a group, we can just simply print the data frame by using get underscore group. So what we have to do is G is in which the all the groups and the data frames are stored, and then we use function G dot get underscore group, and we specify the value math. So it means for this math subject we are going to get that particular group, or you can say sub data frame which was created. Now let's say the requirement is to group the subject group on the basis of subject and gender, and we have to calculate the multiple functions on it. So how we do this, we say student dot group by, and within the group by we specify based on which columns we want to do the grouping. So we are giving two columns, subject and gender, and we want to so apply functions on the marks column. So then we are selecting marks column, and then we have to apply the functions using dot agg, so dot aggregate that we learned earlier, because using aggregate we can specify more than one function. So we can we can make the use of aggregate dot agg, and we can specify the functions here like minimum, mean, and maximum. So we get output something like this. So in the output, so we have subjects, because the first first column that we have specified as the subject. So these are the two distinct values of the subject, maths and science. Then the next comes the gender. So we get gender for math, we have female, male. For similarly for science, female, male. And then for each of these combinations, we are getting minimum, mean, and the maximum value. So that's how we do the grouping. On a data frame. Next is the join. So join is basically used to combine two data frames. Let's say we have data frame D1, which has column A and some random values, and this is the index, which is date time index. And we have data frame D2, which is again having a date time index, and column B, which is having some random values. Now, one thing to note for data frame D1, the date time index starts from 1st of May, goes up to 7th of May. For data frame D2, date time index starts from 3rd of May and it goes up to 9th of May. Now, let's say we want to join these two data frames A and B based on the common index. It means that wherever the date is matching, we want column A, and then we want column B next to each other. So how do we do? So we do it like this using the join function. So we say d1 dot join, and we specify the second data frame, which is d2. Now we are doing an inner join. So it means in the output we will get only those values where there is kind of a equi match, or the exact match between the index values. So from 3rd of May to 7th of May is something that matches in both these data frames in terms of indexes. So from 3rd to 7th of May, we get index values, and then the corresponding to these index values, we get values for column A and B from the data frame D1 and data frame D2 respectively. Now let's say the requirement is that we want to do the inner left join. Just simply we have to change the join method. So d1 dot join data frame d2 and how equals to left. So this will create the left join. That is, it will select all the records from the data frame D1, and wherever there is a match, it will give the value of column B from data frame D2, and wherever there is a missing value, we will get nan. Just like we get it something in RDBMS when when we apply left join or the right joins. We can change the join method from the left to the right join, and so it means we want to fetch all the values from the data frame D2, and wherever there is a missing value in the D1, we will get nan. Now next is the outer join, which is basically like select everything from D1 as well as from D2. Wherever there is a match, fetch the corresponding values, and wherever there is a missing or there is no match found, for that particular display the nan. So in this way we get everything from May 1st to May 9th, and wherever there was a missing value, we are getting nan here. For example, for column B, these two are nans. Similarly for column A, these two are nans. So this is a very useful method to join the data frames based on the index values. Next is if you want to merge the data frame. Let's say we have an employee data frame which contains two columns, employee ID and the department ID, and next is the department data frame in which we have department name and the department code. And let's say the requirement is to generate a data frame or the records such that we get department name also along with the employee IDs. That is, we want employee ID, department ID, and the department name next to it. So what we have to do, we have to merge these two data frames, employee and the department, based on this department ID from this and department code from this. So how do we do this? We say emp.merge, and we are merging employee with department. How equals to inner, this is again the join method. I mean, the way we are going to merge it is like inner or left or right or outer. One of the methods we can specify. Default is inner, and left on means in the left data frame, that is employee, what is the field that we are using to join. So in the left data frame, we have department ID, and on this right data frame, so whatever data frame we specify uh, in this as a parameter to this merge is the right data frame. So in this right data frame, the column which is used is the department code. So we say write on department code. And when we run this, we get a data frame which is having employee ID, department ID. This is coming from the employee data frame. Department name and department code is coming from the department data frame. So you see for D1, D1 actually is HR, so we are getting for employee 10 D1 HR. Now for employee, this employee he is in D2, so D2 means IT. So for D2 we are getting IT. Similarly for D3, D3 means sales. For D3 we are going to get sales. Now using this we can perform some interesting operations on it. Let's say the requirement is from this employee table, or rather from this employee data frame, we want to find out all those employees who work in the sales department. And in the output, I just want employee ID and department ID only. Okay, so I don't want any extra column, but we don't have sales value here. Like we just have department codes, we don't have department names here. So how do we do this? We can again use the make the use of merge. So we are saying emp.merge, and we are merging it with the department, and we are saying how equals to inner left. In the left data frame, the field is department ID. In the right data frame, the field is department code. So this is like exactly similar. And then we are selecting the department name column, for example, department name, and then we are equating it with sales. So select all those records from this data frame where department name is sales. So only this particular record, one record gets selected. Now we are using this entire condition as a Boolean condition, and then we are passing this Boolean condition to this employee data frame. So in this way we will get employee ID and department ID, only those two columns which are there in the original data frame. So this is the employee who works in department D3, which is actually the sales department. So this is a very interesting way to join the multiple data frames based on some uh, common column, and then we can filter out based on our requirement uh, and present the output. So that's it for now in this tutorial. Thank you.